You take a box, remove the item inside, and that box instantly goes from being useful to being considered trash. You throw it straight into the recycling bin or the trash, and that's the end of it. But what if that trash can isn't actually a finish line like we think, but instead a brand new starting line that could fundamentally change operational costs?
In fact, one of the biggest misconceptions in the business world is exactly this kind of binary thinking, believing that a material is either useful or waste. However, when we take a closer look at industrial processes and supply chains, we realize that the waste label is actually applied simply because we lack the right processing tool.
Today, we have on our table some resources that contain quite specific technical details, but whose impact extends all the way to global supply chains.
Yes, the data we have is quite diverse. There are technical documents obtained from the HSM company's website and case studies from companies like ETTOH, Denki USA, and My Products.
And of course, there are detailed engineering data on an industrial machine called the HSM ProfiPack P425. The purpose of our in-depth review today is to discover how this device, which at first glance appears to be just an industrial machine, actually provides a practical solution to major issues such as waste management, sustainability, and cost savings. All right, let's break this down a bit. The sources keep mentioning this device, but how is it different from an ordinary paper shredder? Why is it positioned as such a special device?
Let me put it this way. To call the ProfiPack P425 a standard shredder or destruction machine would actually be a complete misunderstanding of its engineering purpose.
What do you mean? Doesn't this device cut paper in the end?
It does, but standard paper shredders are designed to destroy information or material. In other words, it's meant to make it unreadable and impossible to reassemble. However, the main function of this device from HSM is not destruction. Its main function is reconstruction.
Is it something like recycling?
Not exactly, we could call it more like upcycling. It takes those waste, multi-layered, bulky cardboard boxes that take up an incredible amount of space in storage and physically stretches them to turn them into high-quality, shock-absorbing protective padding material.
I see. It's kind of like, it's like when a master chef, instead of throwing away vegetable peels in the kitchen and wasting them, turns them into a wonderful and delicious gourmet broth.
Oh, that's a really good analogy. Exactly. Instead of throwing the material away, it gives it a completely new and valuable form.
Wait a second. We're talking about shredding or cutting thick cardboard at high speed here. Wouldn't that create a massive cloud of cardboard dust in an office or warehouse environment? I mean, as soon as the cardboard is cut, it would release a lot of particles into the air. How could this possibly be a safe or clean process?
That's a very reasonable question. This is exactly where engineering comes into play. The device doesn't create a dust cloud by breaking the cardboard into microscopic pieces. Instead, it has specially designed cutting cylinders. As these cylinders pass over the cardboard, they punch holes and stretch it without completely tearing it apart.
When you say it stretches, does that mean the rigid structure of the cardboard is altered?
Exactly. The flat, rigid structure of the cardboard transforms into a geometric mesh texture. Think of it almost like an accordion. Rather than cutting, it's more of a pressing and shaping process that gives the material a new form.
Wow!
Absolutely. And when this is combined with the closed enclosure design, dust emission is kept to a minimum. All of this happens within a closed system.
Another detail that caught my eye while looking at the technical data in the sources was the structure of the blades. There's a phrase that keeps coming up. It says, induction-hardened, solid steel cutting cylinders. What exactly is the mechanism of induction hardening? I mean, why didn't they just use a regular steel blade?
Induction hardening is actually one of the most fascinating processes in metallurgy. Basically, it's the process of using electromagnetic induction to heat only the outer surface of the metal to an incredibly high temperature and then cooling it rapidly.
Only the outer surface? Why not the whole thing?
Look, think of it like this. Imagine a loaf of bread baked at a very high temperature but for a short time in the oven.
The outside gets really crispy.
Exactly. A very hard, wear-resistant and brittle crust forms on the outside, but the inside of the bread is still soft and flexible.
So, while the outside of the metal becomes razor-sharp and hard as stone, does the inside stay flexible enough to absorb shock waves that could result from that pressure?
You hit the nail on the head. If those massive steel cylinders were hardened all the way through, the metal would become extremely brittle. That's what we call brittle in English. Under high pressure, it could suddenly crack and shatter.
I see. Since it doesn't flex, it would just break directly.
Yes, thanks to that bread crust-like hard outer surface, the cylinders become so durable that they can easily crush even steel staples forgotten on top of the cardboard.
No way. A staple?
Absolutely, absolutely. Even metal pieces. You don't even need to bother removing the staples. The machine swallows them as if they don't even exist.
It's truly an incredible display of power that it can crush even staples. So if this machine can crush thick cardboard and those steel staples at the same time without any trouble, then the motor turning these cylinders must be drawing an unbelievable amount of power.
Oh, absolutely.
Looking at the sources, it mentions a power consumption of 3,800 watts and a voltage of 400 volts. Moreover, it operates with three-phase alternating current. So, is it really possible to plug in such a beast into a regular wall socket in a warehouse and run it? Why isn't standard electric current enough for this?
Unfortunately, a standard 220-volt single-phase wall socket can't provide the continuous and uninterrupted torque that this machine needs. Let me explain why they use three-phase power with another analogy, if you like.
That would be great. I'm listening.
Think of single-phase current like pedaling a bicycle with just one leg. You apply force, the pedal goes down, and then there's a brief gap, a dead spot, until the next turn, right?
Yes, you experience a momentary loss of momentum.
Well, three-phase current is like pedaling the same bicycle with three different legs in perfect rhythm without ever leaving a gap.
So, there isn't a fluctuation or drop in the power going to the motor. Not for a millisecond. There's a constant, relentless driving force at play.
Exactly. It needs this constant three-legged, uninterrupted power so that when it encounters a steel staple or a three-layer thick cardboard, the motor doesn't suddenly stall, jam, and most importantly, doesn't trip the fuse.
Makes sense.
Thanks to this, the machine can already reach a processing capacity of exactly 120 kilograms of cardboard per hour.
Wait a second, I'm trying to picture this in my mind right now. 120 kilograms per hour. I'm asking so our listeners can also visualize this. How much space does 120 kilos of cardboard actually take up? If we consider that a standard large e-commerce shipping box weighs a few hundred grams, this means that about 300 to 400 massive boxes go into the machine per hour and are transformed into those flexible protective mats within seconds.
That's exactly how massive an amount it is.
So in an 8-hour workday, you could get rid of an entire mountain of cardboard.
This massive capacity shows just how critical the device is for industrial operations. The machine already has power transmission components designed for continuous operation. In other words, it's specially optimized for this intense pace.
Now let's talk a bit about the usability aspect. Because according to the technical specifications, this device weighs exactly 181 kilograms. Its height is also more than 1 meter. Even two people would have a hard time lifting this.
Yes, it's quite a heavy piece of equipment.
So, how realistic is it to use a 181-kilogram, 400-volt machine that shreds hundreds of boxes per hour safely and flexibly in a typical warehouse environment? Wouldn't employees say something like, "I'm not going near that thing, I might get my hand or arm caught"?
Someone working in an industrial environment naturally always seeks safety and control. HSM engineers have also tamed this massive power with a user-friendly interface. First of all, no one needs to be muscular to move that 181-kilogram weight.
Does it have wheels underneath or something?
Exactly. There are industrial wheels under the device that can smoothly move even its fully loaded weight.
So, we can push the device like a heavy suitcase to any station we want inside the warehouse.
Yes, very easily. Moreover, once you bring it to the right spot, you activate the special parking brake system on the wheels. The moment you lock the brake, the device turns into a massive stationary production unit that doesn't budge from its place.
That's really practical. And what about that fear of using it you mentioned?
The second step to overcoming that is the simplicity of the control panel. Most industrial machines have dozens of complicated buttons, switches, and adjustment dials. You know what I mean?
Yes, they usually look like airplane cockpits.
But when you look at the control panel of the P425, you see a touch keyboard with just forward, stop, and reverse buttons, supported by intuitive LED indicators. It's no different from a paper shredder or a printer you have at home.
I guess the reverse button is there so you can intervene immediately if you enter something wrong or if the cardboard gets jammed. But what really raises a question mark in my mind are the safety standards. After all, you're pushing cardboard between steel cylinders. Pinch points, as we call them in industrial terms, aren't they a very serious risk?
That's a very valid concern.
Why wouldn't the machine grab an employee's glove or finger along with the cardboard?
This is a very critical detail. That's why we need to pay close attention to certifications in the sources. This device doesn't just claim to be safe.
Does it have documentation?
Yes, it has GS and TÜV Süd certifications, which represent German safety standards, as well as UL listing, which is one of the strictest safety tests in the American market. For example, UL standards for certifications examine the geometry of the machine's feed opening down to the millimeter. The angle and depth of the opening must be designed in such a way that it is physically impossible for a human finger or clothing to reach those steel cylinders.
So even if you wanted to, you couldn't touch those cylinders with your finger.
Exactly. There's a physical barrier. In addition, there is a huge red and yellow emergency stop button located at the most visible and easily accessible point of the device. If that button is pressed in any moment of panic, the electromechanical system instantly cuts all motor power.
So the device is surrounded by a complete safety shield that leaves no room even for user error. So what about the noise level? Steel cylinders, crushed metal staples, a massive three-phase motor. Shouldn't it operate with an ear-splitting noise? After all, this is also a major issue in terms of occupational health and safety.
If it were standard engineering, yes, you couldn't stand next to that machine without wearing ear protection. However, the data in the sources tells us that the device's idle noise level is only around 63 to 64 decibels.
No way. Only 63 decibels?
Yes, it's hard to believe, but that's the case.
Hold on a second. That's almost equivalent to the sound of a heated discussion in an office meeting, or, I don't know, the noise made by an ordinary laser printer running in the background. The fact that a 181-kilogram machine can operate this quietly is clear proof of just how advanced its vibration insulation and motor body isolation are.
Absolutely. When you also consider the fine details like the integrated ruler system that lets you adjust the working width of the device and the thickness adjustment, the operator doesn't fear the machine. Instead, they embrace it as a quiet, harmonious co-worker completely under their control.
All right, so what we have here is a safe, quiet, user-friendly, and unbelievably powerful machine. But now, I want to move on to the philosophical and practical aspects that are reflected in company balance sheets.
Of course, that's really the most crucial point.
Because at the end of the day, how do these devices change the overall operations of the companies whose warehouses they are placed in? In case studies, we see that this device has very significant effects beyond just being a corporate conscience or a PR tool.
Yes, this is actually the most striking part of the issue. The case studies prove to us that it's not just about buying an environmentally friendly machine. For example, let's take a look at the case study of Ito Denki USA from our sources. Their motto is very striking. They say, getting greener while saving money.
In other words, becoming greener while saving money.
Exactly.
This is actually a very rational approach, because companies usually see sustainability as an expense item, like a social responsibility project budget. However, this case study shows that being environmentally friendly can actually turn directly into a revenue model. So how do they do this? Are we talking about a double-sided cost reduction here?
There is definitely a double-sided gain. The case study of the platform called My Product explains exactly this mechanism. They create a closed loop with the packaging material they produce themselves. The system works as follows. Every day, hundreds of cardboard boxes filled with raw materials or products arrive at the company.
This is a very standard situation for e-commerce sites or warehouses.
Normally, after emptying these boxes, you have to break them down so they don't take up space and regularly pay a waste management company to come and collect that trash. The rental of garbage containers, regular waste collection schedules, and so on. All of these are very significant operational expenses.
That's right. This is the cost on the waste side of the business. And of course, there's also the packaging side of it. You buy meters of bubble wrap, plastic air cushions, or styrofoam filling material from outside to wrap those fragile products you're going to send. You pay a fortune for those. And I think what's even worse is that those plastic filling materials take up massive space in your warehouse. You're basically paying rent to store air. It's so ridiculous.
Companies are completely stopping the purchase of those plastic filling materials from outside.
So supplier invoices suddenly drop to zero.
Exactly. At the same time, since they're getting rid of their waste cardboard, they completely eliminate those recycling and transportation fees they pay to waste companies. Waste instantly turns into value. It actually becomes the raw material for its own solution to its own problem.
I think this is truly an operational revolution. So, if we are to summarize these impressive resources, technical documents, and case studies on our table. In today's in-depth review, focusing on the HSM ProfiPack P425, we explored how industrial design, advanced engineering, environmental awareness, and of course, economic efficiency come together to form a mutually reinforcing mechanism, all starting from a piece of waste cardboard.
Yes, it was a very comprehensive topic from every angle.
I think this device clearly and tangibly proves to us that most things we label as waste in industrial life are actually valuable raw materials, just waiting for the right conversion tool.
I completely agree. What we were looking at wasn't just a machine that cuts and shapes cardboard. It was a very powerful bridge that repaired those breaks in the supply chain, reduced companies' dependence on external sources, and brought that magnificent cyclical system of nature right into our concrete warehouses and offices.